Hello, welcome to ANS Solver. This is the sixth question of the paper. So, the time taken by volunteers to complete a certain task is normally distributed. In the past, the time in minutes has had a mean of 91.4. So, this is my mean. The standard deviation, okay, is 6.4. So there's a new similar task. So here they are testing it with time t minutes is taken by a random sample of 6 volunteers. That means my n is 6 and is summarized with the summation of t as 568.5. So they are testing this at a 5% significance level of whether the new task is different. Okay, different is important from the mean time for the old task. So give a reason why Andrea should use a two-tailed test. Because she's testing for difference. You're testing for difference. Okay. See, whenever we test for increase or decrease, we use a one-tail test. But here they don't know whether the mean time will increase or decrease. They are just saying the mean time is will not be equal to 6.4. Oh sorry, not 6.4, 91.4. My bad. Okay, this is what they are claiming. So that's why Andrea should use a two-tailed test. Now, state the probability of a type 1 error is made, okay, and explain the meaning of a type 1 error in this context. So, type 1 error basically means when you reject your null hypothesis, but your null hypothesis is actually true. So, you've made an error. Or in simple terms, you can just call it the probability of the significance level, because that's the area of your rejection. So if you see, the significance level they have given us is 5%, which in probability can be written as 0.05. Okay, and now in this case, type 1 error basically means when you conclude when you conclude that mean time, which is 91.4, has changed or is different, but has not actually changed. That's why it's an error. Okay, this is what you can write. Now, you may assume that the times taken for the new task are normally distributed. Stating another necessary assumption, carry out the test. So the first assumption you're stating is that the standard deviation is same, where you're claiming that the standard deviation of 6.4 is not changing. Okay, because it's a new test, so this is what you're saying. So this is the assumption. Okay, now you carry out the test. So to carry out the test, I know my null hypothesis. Okay, first write everything. You know your mean is 91.4. Your standard deviation is 6.4. Okay, the number of people you are taking is 6. But what is your test value? Your test value is basically the summation of t over the n. You know your summation of t is 568.5. So I can write this as 568.5 over 6. Okay, so I'll do this on the calci, 568.5 over 6. So I get my answer basically as 94.75. Got it? So now what we need to do is, I know this is my normal distribution curve. Got it? My significance level is 5%. Okay. But before I do that, I know my null hypothesis. I'll just write my null hypothesis. An alternative, that's how we carry out the test. My null hypothesis states that my mean is 91.4. But my alternative hypothesis states that my mean is different or not equal to 91.4, which is why we carry out a two-tailed test. So on a normal distribution curve, it looks something like this. Okay. So now I know the area, which I'll shade in red, okay, is basically adds up to 5%, which is 0.05. So now if I divide 0.05 by 2, I get 0.025 here and 0.025 here. And in the middle, I know I have 0.95, correct? Because 1 minus 0.05, which gives 0.95. So I simply need to calculate the Z value here for both of these. So for this, I need the area which is less than this Z value, which is 0.95 plus 0.025. So 0.95 plus 0.025 gives me 0.975. So I'll scroll up to the table. I have my table here, I have the set of critical values. I need the probability for 0.975 and I know the Z value for that is 1.96. Got it? Because Z. So I'll scroll back down. Okay. So I know this is basically 1.96, and because it's symmetrical, this is minus 1.96. So now I need to calculate my Z statistic value, which will be given by the mean or the test value minus the mean over the standard deviation over the root n. So my Z statistic value will basically be equal to, I know my test value is 94.75 minus my mean I know is 91.4 over the standard deviation I know is 6.4 over root n, which is basically root of 6. So you can solve this on the calci. Okay, even I'm doing it. Just give me 1 second. 6.4 over root 6. So when I do this, I get my Z statistic value as 1.282. Okay, now I compare my Z statistic value with, because it's positive, let me compare it with 1.96. So I compare 1.282 with 1.96. If I see 1.96 is greater, that means I do not reject the H null or the null hypothesis, okay, and no evidence that the time, or she's basically testing for to test whether the mean time is different. So no evidence that mean time is different. Okay, because if you see, think about it graphically. Where does 1.8282 lie on the curve? It lies somewhere here. Okay, and my critical region is the area in red. So the line in green does not fall on the area in red. So I do not reject my null hypothesis, and there's no evidence of the mean time changing.